Okay. Uh, Vivas, Kosik, Anup. Anup was not there yesterday, right?
Yes.
So have you installed the software?
Sir, I have given him the link. He has installed, sir.
Okay. All right. So are you able to see that screen that I showed yesterday?
Yes, sir.
KENPAVE. Okay. All right. So what we were doing, we were calculating the permissible strain, where what is it? Second. Sorry. I am audible now, right?
Yes, sir.
Okay. So we were basically finding out, soil subgrade, this granular base plus granular subbase, and this is bituminous mix, 2 layers. So in this 3-layered system, we are finding the tensile strain at the bottom of the bituminous layer and vertical strain, compressive strain at the top of the subgrade. So there are two types of strain. One is permissible, which we calculated based on the design traffic, that if the strain generated is less than this permissible values, then we can say that our pavement will not fail like in its design life. All right. But if it exceeds, then we can say that the pavement will fail, and in order to uh, ensure that the pavement doesn't fail, we need to alter something. What we can alter? We can alter the vehicle load, which we should not, because IRC has given some standard weights, 80 kilonewton for dual wheel on both the sides of the axle, then 65 kilonewton for a single axle with single hole on either side. Then changing the vehicle configuration, that also we cannot do because IRC says that the standard one for analysis should be this one. That means a single axle, dual wheel. Single axle, this is one axle, and dual wheel. Two wheels will be on each side of the axle. Okay. Then we can try changing the materials which is used, or we can simply change the thickness of the layers. So mainly we will try with this one. We will increase the thickness of the layers if our generated strain is coming greater than this permissible values. So this permissible at these two interfaces we have already calculated using these two formula. So this gave you your vertical compressive strain, and this gave you your tensile strain, right? So we got this as 155.47 and 330.73 microstrains respectively. Now, if you see here, basically, as per IRC, there are two critical locations. Like if you see, suppose I have applied a load like this, okay, and this is another material. This is a material 1 and this is a material 2, and from which I have applied some load. Now we know that at the center there will be always a critical point, so we need to figure out at the center what is the strain. Okay, and also we know that because of this shearing action, there will be again a critical plane on the by the side of this, like the wall, if it is extended like this here, means throughout this side. Okay, and since this is symmetric, so like if I take one more here, and since this is symmetric, if I take another one here which is like center of gravity of these two loads, so this is P1, this is P2, so P1 center of gravity is this, P2 center of gravity will be this, then this is your because of the shear action, again we can take here because of the shear action, and center of gravity of the two load system, that is P1 and P2, will be somewhere here. Okay, but this is symmetric, right? Both this P1 is equal to P2, right? So in that case, what will happen? We can simply check here, then here and here, because this one, this x will be equal to x1, x2 will be equal to this x1, and here again it will be say x3 will be again equal to here x4, like that. So since this is a symmetric system, we don't have to calculate at all this 1, 2, 3, 4, 5 planes. We will simply consider these 3 planes, 1, 2 and 3. So this is just your, I am talking about this axis. Let's consider this x-axis. So I am talking about x-axis. But what about the z-axis? That means the depth. What about that? So there we have to consider here and here. Okay. So again, let me see again how many points will be there. So one point will be here. Can I use different color? So this is point 1. Again, this is point 2. This is point 3. This is point 4. This is point 5. This is point 6. So at 6 points, we need to find out the strains. Here we are concerned about only the tensile strain, and here we are concerned about only the vertical strains. Anyway, moving next. Now this thing, this tires, it is coming like it is resting at the top of the rod like this. So any tire which is resting at the top of the rod like this. So what do you think the imprint shape will be generally? What should be the imprint shape? So just take one tire and you just color it with some black paint. Okay, and then you take the tire vertically and you simply keep it on a white floor. Then again you take it back. So after taking it back, if I see from top view, what will be the imprint, you know, uh, shape? I am giving you some options. Whether it will be like this, it will be like a rectangle, whether it will be circle, or whether it will be like this. Which one? 1, 2, 3. Which shape do you think?
Sir, the third one, sir.
Third one is the perfect one. Okay, so it's basically a combination of semicircles, two semicircles and one rectangle. So semicircle 1, semicircle 2 and one rectangle. But in order to make the calculations easier, we convert this entire thing. Suppose we calculate the area. Suppose this semicircle and this semicircle will combine together and it will form one circle, right? Suppose the area of this circle is A1. Then again, area of this rectangle is A2. So what we do, we consider A1 plus A2 and we get some A, total A. Then we convert it to a circle which radius, where radius is calculated by this formula. Are you getting? So
Yes, sir.
an equivalent circle is created which has the same area as this shape. Okay. So now in this case, if you see, I discussed in our last class that standard axle load as given in IRC for single axle dual wheel. That means axle is single, dual wheel on either side. It is 80 kilonewton. Okay, and we have converted everything to this axle by multiplying with VDF, if you remember, right? So all these loads have been already converted to these axles by multiplying with the VDF. So now if I say 40 MSA, in our case it's 84 MSA, that means 84 million axles of this category is passing through the road or will pass through the road during its entire design life. So we don't have to consider other axle categories, other axle types, only this one is sufficient. Okay, now this is 80 kilonewton. Now let's divide this 80 into 4 because there are 4 wheels, and if all the tires are equally inflated with the same pressure, then the load coming through all the tires will be equal. So you can simply divide 80 by 20 and consider the load coming through one wheel is 20 kilonewton. Okay, and this is the circular imprint, that is we call tire imprint. Okay. Tire imprint is circular. Alright, now the problem is we cannot measure the area every time. Okay, so that's why it is assumed that the tire pressure for the vehicles is 0.56 megapascal. If you see, this same pressure is like maintained when you go for tire inflation. So they will check the pressure, right? So they may check in PSI or something, but they will ensure this one because this is government regulation. Now, can anybody tell me what if I inflate a dryer with a much more higher pressure, say 1 MPa? Then what will happen? What will be the consequences?
Sir, the impact force on the surface would be much more.
Yeah, because
Area would be less, so
area would be less, so the same 20 kilonewton will be concentrated in a smaller area, and when force divided by area you get stress, its stress will be much higher. So when stress is higher, what will happen?
Sir, the pressure is more.
damage would be more.
Damage would be.
When there is a stress, there will be strain, right? So strain generated will be more. So when strain is more, then the pavement will fail like in a faster manner. Okay, so you are correct. The damage will be more. So that's why. But what are the why people generally go for higher tire pressure? What is their advantage?
Sir, the fuel economy is better.
Fuel economy is better. And why do you think so?
Sir, because because of the like elasticity of the wheel, the higher the tire pressure is, it is easier to drive the vehicle.
Yeah.
So lesser the friction.
Yeah, you feel less friction because area is reduced now, and because of that, the vehicles will go faster. But ultimately, you are damaging the pavement and the cost of that, right? So that's why this is government regulated value. So since this is constant, this is also constant. So can we find out simply like what will be the contact radius, right? So this P by P, this will give you the area, right? F is what? Force by, sorry, stress is what? Force by area. So this P is the force, which is like 20 kilonewton. This A, you don't know. And here it is pi r square. And this sigma is considered equal. That means the contact pressure is assumed equal to the tire pressure. So this becomes your tire pressure small p. Okay. So this becomes your tire pressure. So can you find out this A? A will be how much? Capital P divided by small p. Did you do this type of calculations in highway engineering?
No, sir.
No. Okay. So yeah, that will give you A, but it is not enough. What do you need? This A is pi r square. So basically R will be again P by P. Pi will be coming here. So understood this formula, why it is like this?
Yes, sir.
Okay. So can you cross check whether this is coming as this? Got it?
Yes, sir. It's 0.1066. Yes, sir. It's the same.
Yeah. So you can write L166 centimeter. Now you see, these are the points I was talking about. So now we know that the tire implant, this radius, this R, is not unknown. This is your 10.66. So that means what will be this much? What will be the width of the tire? Oh, come on. See, this is same, isn't it?
So 21.32.
Yeah, it will be just double of it, right? It is twice it. So now, since in our case, our critical points are this one, number one, this one, like coming just by the side of the wall of the tire, and exactly at the center of this two tire, and this distance, center to center spacing of two tires. So don't confuse with this tire and that tire. Okay, these two are from same side. Okay, 32 centimeter will be how much? You take a scale that is normally 30 centimeter. So 32 centimeter will be this much. So remember that is center to center spacing. So if you deduct 10.66 from this side, it will be hardly 11 centimeter. This much. Okay. So this much is really the gap between two tires in a truck. Okay. Understood?
Yes.
Alright. So why we are considering only this thing, not this one?
Sure, because the area of influence of the tire does not reach the other.
Yeah, it doesn't reach, or it is symmetric, right? If we consider for this thing, then automatically this is symmetric, and this is not influencing this one, this is not influencing this one. So that's it. So the other 3 points are at the top of the subgrade, 4, 5, 6. So can you draw this and find out? So this distance is y, this distance is z. So this direction is z. So basically this is, and that direction in which the vehicle is moving, that direction is x in our software, the software which we are going to use. Okay. Alright. So this point will be this we can consider 0, 0. Okay. So that will be 0, and this thickness was how much? 15 centimeter, right? And this was how much? 15 plus, this was 15 centimeter, 150 mm, this was 250 mm, right? 150 plus 200, 600 mm. So that's why in centimeter it will be 60 centimeter. So here is 60. So any doubt till now? Are you getting how this coordinates of these points are calculated?
Yes, sir.
Okay. So have you completed? Noting down the coordinates. Yes or no?
So still drawing, sir.
Okay. You can write like this also, 16, 60. You'll understand. This is YW, Z. And let me know when you are done.
Done, sir.
Others? Done? Yes, I spot and there is or no. Manjit? Completed? Hello?
No, sir.
None, sir.
Done. Arnab? Ready, sir? Don't simply just copy. Try to understand why these coordinates are coming, why 60, why 10.66. Okay. So now can we move to this software part?
Yes, sir.
Okay. Everybody, is the software installed?
Yes, sir.
Yes, sir.
Okay. So okay. So are you getting a screen like this?
Yes, sir.
Okay. So the first step is you select layer input. So if you are not able to do, let me know. So select layer input, this asphalt. So this part is used for flexible pavement design and this part is used for concrete pavement design. So we'll basically do this part, asphalt. That means flexible pavement. So click on layer input. Can you see a screen like this?
Yes, sir.
Okay. So now click on the first input. Okay. Just underneath file, you can see one input in red color, right? So just click here. Oh, sorry. In file, you have to click new first. File, new. Okay. Then file is created. Then go to general. Then input. Under general, you see one option, input again. So you click there. Clicked. Are you getting the screen?
Yes, sir.
All of you?
Sir, can you repeat once?
Go to file, create new. Okay. Then go to general and create this new. Sorry, this input. Click on this input button. Are you getting?
Yes, sir.
Okay. So now here you need to give different, you know, options. So options and their descriptions are written here. So you don't have to worry like which option, whether you should write 1, 0 or 2. So what each number signifies, everything is written. Okay. So first is asking type of material. So type of material, you should always type 1 because we are considering the materials to be linear. You know, some assumptions are there that the material should be linear, it should be homogeneous, like that. So our first assumption is the material type is linear. Okay. The second question is damage analysis. Whether do you want any damage analysis or not? So in concrete pavement design, you will learn what is damage analysis. But here we are not doing damage analysis. So you need to. You don't have to do anything. By default, it is 0. Okay. If you click, it will go. Then you have to write. So just follow me carefully. So damage analysis, you don't have to care. Number of periods per year, it should be 1. Why 1? Because we are not varying the seasons. So generally you can also vary during summer, during winter, during rainy season, like that you can vary different periods in a year. But here we are not doing that. Okay, so it's only 1. Number of load groups. How many load groups are there? If you are confused, you can see here. it's not written here also. But load groups we are considering only one, right? If it is a tandem, like two different load groups would have been there, then it would have been two. But in our case, we are considering only single XM, right? So only one load group. So that will be again one. Tolerance, no need to touch. Number of layers, by default it is 3. Let it be 3 only, because the first layer is the bituminous mix, which is combination of surface and binder. The second layer is granular layer, which is combination of base and subbase. And the third layer is subgrade, which is basically soil, right? So bituminous mix, granular layer, and then soil subgrade. 3 layers. Number of Z coordinates for analysis. Now can anybody tell me how many Z coordinates are there for analysis?
Sir, 3 Z coordinates.
Hmm?
3 Z coordinates.
No, it's 2. How many variation in Z? 1 at the depth of your bituminous mix, I mean at the bottom of your first layer, and the second variation in Z is at the top of the subgrid. So Z equal to 15 and Z equal to 60. Only these two coordinates in Z, right? No?
Yes, sir.
So 2. So, yeah. It's 2. Okay. Don't have to touch the other things. Okay. Can you check whether it is 289 111? Is it like that?
Yes, sir.
Okay.
Yes.
You have to change the last one, because you see system of units. So 0 for English means this FPS system, pound and all, and 1 for SI. So we will be using SI unit, so we need to write 1. So like very carefully, please cross check whether you have entered same as mine, 1011, then 0.0013, 289, then all the rest is 1. Done.
Yes, sir.
Now click on OK. Click on OK. I think I have lost it. Now, are you back to this screen again?
Yes, sir.
And if you notice under general, now it's written done, right?
Yes, sir.
Now you see in Z coordinate, again it is coming as input, right? So you need to click on that input. Second, I mean untitled, done, then input. So you can click on input. Now it is asking the coordinates, okay, the Z coordinates. What are the variation in depth? So what will be its value? You will tell me point number 1 and point number 2.
Sir, 1 point is 15, second point is 60. Sir.
Okay. Actually, I should use the other laptop where this keyboard is not connected. So I think because of keyboard कहाँ पे है? Huh? So okay, let me switch to my other laptop. Okay, can you see my second screen?
Yes, sir.
Okay, just follow that screen. Okay, so now under Z coordinate you are seeing one option, input, right? So click on that. So here in the first one you write down 15, in the second one you write down 60.001. Because why? If you write exactly 60, it will not be able to differentiate between the layer above it and layer underneath it. It will be just in the middle of these two layers, so you will not get a proper result. Since we need at the top of the subject, so that's why we have intentionally given some extra value. So you can write anything, 60.001, 60.01, anything, but just little bit more than 60 so that it goes into that subject layer. Okay, are you able to do it?
Yes, sir.
Then again click OK. Now you can see Z coordinate is also showing done. Next, layer. So in layer, you click on input. Now you will see different thicknesses are there, right? So these thicknesses you can write, I think, by yourself. Can you tell me what is the thickness of this layer 1? What is the thickness of layer 1?
So 40 mm.
Layer 1 is the top layer. It was 150, I think, right?
150.
So
150, sir.
it's centimeter. So you need to write down 15.
15.
Okay. In case of the second layer, what is the value? You drew this diagram yesterday, right?
Yes, sir. Second layer is, sir, the base layer, sir, right?
Yeah,
The base plus sub base, it's 450, sir.
450. So 45. Okay. 3 layers. First one is like surface and binder combined. That is the entire bituminous mix. Second layer is your base plus sub base combined, the entire granular layer. The third layer is your soil substrate. Okay. Now, thickness of the third layer is not asked. Why? Because we have assumed it to be half space, semi-infinite. Okay, that's not correct. PR is Poisson's ratio. Okay, so how much? What are the values of Poisson's ratio?
0.35, sir. 0.3. So both are 0.35. And the last one is 0.30.
No, this is also 0.35. Okay, so all are 0.35. Okay, now click on OK. Just click on OK. Now you will again go back to the main screen. Now, if you have noticed, under layer it is set done, right? Now don't go to interface, directly you can go to moduli option. Okay, under moduli you see that input option is again coming, so you click on input. Are you getting this screen,
Yes, sir.
all of you?
Yes, sir.
Okay,
Yes, sir.
then just click on period 1. So you see the elastic modulus of all the layers, or you can say the modulus of resilience of all the layers are asked. But look carefully at the unit. So what will be the units? Means what will be the values? Can anyone tell me? What will be the
Sir,
first?
first one was the 3000 megapascal.
So in
Yes.
kilopascal it will be
So
3000,
2000
then again
and
1000,
three more zeros.
three more zeros, right? So 3, then 6 zeros.
Yes, sir.
Okay. What about the second one?
The second one, it was a 224.4.
So 224, then 4,
What about
4, 00. Okay. What about the last one?
so it was a 71.8.
71.8, 00. In kilopascal, it will be like this. Do you agree?
Yes, sir.
Okay. Now click on OK at the bottom of the screen. Okay. Now this is done. See, if you would have given different periods, then during summer, during rainy season, this modulus will change because it will see soil will be in contact with water, so its modulus will be decreased. This elastic modulus and all. So we can create that scenario also, but no need. We will consider that throughout the year it is same, or we are not considering that the modulus of resilience will deteriorate, will decrease with time, but with time it decreases. Initially, if say elastic modulus of the soil surface that you are using says 71.8 megapascal, after 2 years it will be less. Okay, so if you are doing in details, then you have to simulate this condition also. Okay, so only period 1 done. Again you click on OK. Okay, so under moduli section, now is it showing done?
Yes, sir.
Okay, now go to load, then again input. Under load, click on load. So what is it showing? Load group number, right? So again here it is. If you see load, what number you should write, it is already written here. Load or type of loading, assign 0 for single axle single tire, 1 for single axle dual tire, 2 for tandem axle, and 3 for tandem axle. Now can anyone tell me what shall I write here?
1, sir.
1. Why? This is single axle dual tire. Right? What can be shear? Any idea? We are talking about
contact radius.
Contact radius. Very good. How much shall I write here? Let's just
So 10.66 centimeters.
10.66. Okay. What about this CP? What can be the CP?
So contact pressure, sir.
Yes, it is already written here. Contact pressure. So what shall I write?
0.56 kp. So,
Wait.
560.
It's kilopascal. 0.56 megapascal. So it will be 560 kilopascal. Now here, what is YW? YW, you see, center to center spacing between two dual tires along the y-axis. Okay, now who will tell me this? Vivas.
So 32.
32. Very good. This will write 32. What is XW?
So center to center spacing between two axles.
Two axles. Do you have two axles? We have only one axle, right? Single axle. If it is in a tandem axle, then this distance, like two axles are there, like this, then like this, then this distance would be your XW. But here, no, it's a single axle only, so 0. And NR or NPT, that means how many points are there, like in every layer. Okay, we have considered two layers, one at z equal to 15, one at z equal to 60.001, right? So at every layer, how many points are there?
So 3 points.
3 points. So I will write 3. Okay. Now don't press OK. you double click on this 3. Okay, double click on this 3 where you have written 3. Are you getting a screen like this?
Yes.
Everyone?
Yes, sir.
Okay. Bidisa, are you following? Are you here?
Yes, sir.
So are you following?
Yes, sir.
Okay. So can you help me? See, X value, as I told, it is in the direction of the vehicle. So it is going like this. The tire is like this. So it's the direction of the vehicle. So I will tell that all my x's will be 0 0 0. So point number 1 x 0, point number 2 y 0, and point number 3, sorry, x 0, point number 3 will be again 0. So what will be my y coordinates in both the layers? Vidisha, can you tell? We have just written in the diagram. So what will be the values? Oh no. Vivas. Switch.
Sir, 0, 10.66.
Switch to my this screen. Is my the second screen available? I think it's available, right? Can you see my like the earlier screen where the tires
Yes,
are
sir.
coming? So you can see here. You can see.
Yes.
I am talking about. See, x is like perpendicular. It is the perpendicularness. It's going like this because it's the vehicle is moving like this. So I am talking about my here. Y is this direction is y. So here y is how much? 0. Here y is how much? 10.66. And here y is how much? 16. Why 16? Because it is 32 by 2. Right? Are you getting?
Yes, sir.
Yes, sir.
Okay. So what shall I write here? Point number 1. Proceed.
Sir, 0.
0. Then point number 2.
So 10.66.
10.66. Point number 3.
So 16.
16.
16. Very good. Okay. Now done. Are you seeing the screen now? Okay. Again, you have to click OK. So that.
Sir, the X points will be 0, sir.
Yeah, x points are 0
Oh,
because
X points are 0.
if it is 10 dimensional, then like we would have considered the other wheels also. Single axle, so there is no x direction.
Okay, sir.
Okay. So now this general done, z coordinate done, layer done, modulus done, load done. So that's enough. Now click on save as. Okay, save as. So I write ZIST demo 1. Okay. So you check where it is coming. In my case, it is my C drive under the folder KENPAVE. ZIST demo 1. Click on save. So it is saying that file with file name ZIST demo 1 has been saved. Okay. Click on OK and wait. Are you able to do that?
Yes, sir.
Yes, sir.
Okay. So now click on exit. You can exit. Now what we have to do? We have to run. We have to run this simulation. So for that, you simply click on can layer. Okay. And directly you will see this screen that it is done. So please click OK button to exit. Are you seeing this?
Yes, sir.
Okay, so just click OK. All right. Now the last this one option is L graph. That means you can see whether you have plotted the points correctly or not. So is it coming like this? So
Yes, sir.
first layer 3000 ampa, poison ratio 0.35. Second layer this much kilopascal, poison ratio this much. This what are the thicknesses? 0, 15, so 45. So 15 plus 45, 60, like that. And contact radius 10.66 centimeter. Contact pressure this much. Dual spacing 32 centimeter. And you have, if you see here, you can see 3 points, 3 purple points. Are you able to see in your screen?
Yes, sir.
One at the center, one at the edge of the wheel, and one at the center of the two wheels. So is it coming same?
Yes, sir.
So
Yes, sir.
you will also see one option, want to print on the printer. If you select yes, then you can save it as a PDF. So I am just going to desktop, KENPAVE, again JIST. Okay, so as a PDF I can save. Just for future reference. Okay, done. Okay, so in a PDF file you'll be able to select this. All right. Now we need to know the strain values, right? Ultimately, we are doing all these things to know the strain, tensile strain and vertical strain. So in order to know that, you can click on editor and simply go to file, open, and directly you can browse your folder if it is not opening. Then what name did I give? JST demo one, right? Okay. So are you able to look at your file?
Yes, sir.
Okay. So simply open this text file.
Sir, I am getting the same warnings.
Okay. Okay. We'll go there and open. So let's go there. Let's go there. Let's go there. 60. KENPAVE. JIST. Here's it's JIST. Okay. I think if you go to the folder and open, you will be able to open. Are you able to open?
Yes, sir.
All of you? Yes or no?
Sir, I'm browsing.
Okay. Open Vidisha. Are you following?
Yes, sir.
Yes, sir.
So are you able to open this file?
Yes, sir.
Okay.
No, sir.
No. What is the problem? Oh no.
Sir, মই এইটো পইণ্ট কেইটা বহুৱাতে হোৱা নাছিলে স্যাৰ, সেইকাৰণে মই প্ৰব্লেমটো ইনপুট কৰিব পৰা নাই স্যাৰ।
Okay, okay. একো নাই. This class is being recorded, so later on also you can try. Okay.
Okay, sir.
Okay. So now if you see, I get a file like this, right? So here, if you see point number 1, 2, 3, and everywhere there are 2 points again. 1, 1, 2, 2, 3, 3. So if you look at the coordinates, you will understand how these points are, different. So it's telling the vertical strain. So 15, 60, 15, 60, 15, 60. That means in terms of y-axis, it's given like this. So how can I understand? if you open the PDF, you can see these three purple points, right? These three purple points, right? So if I say simply tell that this is my point 1, okay, this is my point 1, this is my, I think you are understanding, right? So this is my point 1, this is my point 2, this is my point 3, and this is the top view, right? You are looking at the pavement from the top. This is the circular imprint of the tires, right? So this figure and this figure, they are completely different. So just concentrate on these two circles. Okay, so the tires are here, like they are coming out of your laptop, just think like that. So this point is basically your y equal to 0, and this point is y equal to 10.66, and this point is your y equal to 16, right? And for every point, for every like value of y, you have again another set here. Okay, so if you are considering here, then the second set is here at the top of the subgrid. If you are confused, go to my second screen. Go to my second screen. Are you confused or are you getting?
So I'm getting.
Understood. Understood, sir.
Understood, no? Okay. Let's not waste time. Okay, so this 1560, 1560, 1560. So here it's not written, but if you see, you can see that 1, 0, 0, 2, 0, 10.6, and 3, 16, 0, 16. So it's basically this y coordinates 0, 10.66, and 16. Now, for vertical compressive strain, okay, at the top of the subgrade, I need to or let us discuss these things first. Okay, this is the vertical coordinate, this is the point, this is the vertical stress, how much stress is getting generated, and followed by strain. That means this 105.282 is the stress. Okay, you are applying some load, so stress will be there, and if you see, stress here is 105 kilopascal at 15 depth, 15 centimeter, at depth 60 centimeter, it's how much? 18. It is significantly reduced, you can see here. And when you are moving, okay, that is at the center of the tire, the first point 0. When you are moving to the second point, it is radially distributing, right? So you can see from 105 it has become 97. Okay, and it is again like this one has, again it has 19.32, because there may be some, because of these two wheels, there are some overlapping, that's why it has increased from this 18. Okay, so from 97 to the third point it is 92, and it is 19.46. This is vertical stress. But do you need to know the stress? No, we need only strain. So consider this thing only. E minus 0.4 means 1. This means 1.758 into 10 to the power minus 4. Okay. So can anyone tell me where do I need to see these values? Like at z equal to at depth 15 or depth 60, the vertical strain. At which depth we need to see?
So z is equal to 15, sir. This corresponding values.
Can you come to my second screen?
Yes.
Where where epsilon v is being shown, this vertical strain.
So Z is equal to 2. Second.
Second one, right? Z equal to 60. So this value we can, this line we can ignore, this line we can ignore, and this line we can ignore. Now out of the remaining three, right, it can be either at the center of the wheel, by the edge of the wheel, or center of the wheel assembly. We need to see which one is highest, because we don't know whether the highest value we will get at the center of the wheel, at the edge of the wheel, or at the center of gravity of this both wheels. Okay, so we need to check which one is highest. So if you see, the highest is,
Third
so
one.
we need to compare this 265.7, 282.5, and 284.7 microstrain. So the third one is highest. Okay, so please write down. You write down the coordinates also. I think you will be able to write down the coordinates now. Third means 16 in between the center of two wheels, 16 and 60. So at that point it is 284.7, so it is highest. Understood?
Yes, sir.
Okay. Okay. Now for tensile strain, where do you need to check? At which depth? Z equal to 15 or Z equal to 60?
So 15, sir.
15, because we check it at the bottom of the bituminous layer. So at Z equal to 15, if you check this, we need to check this one, intermediate P stress. Okay, intermediate principal stress. So horizontal, and it is saying in horizontal principal strain. So here in the last column, the last one you need to check. So one option is how much? 172.8 microstrain. Okay, then 174.3 microstrain, and the last one is 171.6 microstrain. So which one is highest?
Number 2, sir.
Number Sorry, I lost my connection. Are you there?
Yes, sir.
Okay, let me connect. Okay, so I was asking, are you getting what I am trying to say?
Yes, sir.
All of you?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, very good. Okay, so this is just, we have summarized. If you see this, like this, all these things are written here, like this, like this. You click on OK. You can print this. You can go to the file, and here you need to find out like which values are maximum. So our values are, the maximum vertical strain is 284.7 and maximum tangential strain is 174.3. Now next what? After knowing this, what is the next step? We'll tell. We'll tell. So these are the strain values. Okay, these are the strain values at all the points. I have just written to, for better explanation. So from this, all the values, all the values I have written here. So at this point, this is this much. At this point, this is this much. At this point, this is this much. So the maximum one is coming here, like at the center of this, for vertical compressive strain. For tangential strain, it is coming here at the edge of the tire, to here. So that doesn't matter anyway. So the maximum is this one, this and this. So this is our generated strain. These values are generated strain. Now what is the next step? We'll tell.
Now we need to compare
Compare with which value?
the previous values that we found out of EV and ET. Oh, epsilon V and epsilon T.
Yeah, that's the permissible strain, right? So we need to compare. So is it okay or is it not okay? Permissible.
One is okay, one is not okay, sir.
Yeah, permissible should be always higher than the generated one. Okay, so we can say that the pavement will not fail in terms of rutting. That means there will not be any rutting in the pavement, but it will fail in fatigue cracking. Okay, so what can you do now? What can you do? You can see these things can be altered by changing the vehicle load or vehicle configuration. But these are already fixed by IRC. You cannot change the vehicle load. You have to always take 20 kN only for one tire, one wheel. Okay, vehicle configuration you have to always take single axle dual wheel. So that also you cannot change. So what you can change? You can change the material used. So that means, do you need to change? So here, this is okay. Okay, this is okay. This is not okay. Okay, this is not okay. So do we need to change our soil or this thing? What do we need to check? What do we need to change here? The problem is at the bottom of this bituminous mix, right? So either you increase the modulus of resilience of the material, or the second option is you can increase the thickness. Earlier you took how much? What was the earlier thickness? 150 mm, right?
150.
And it was 40 plus 110, right?
Yes, sir.
40 plus 110. So 40 plus 110. There are two layers, remember. This one is 40, this one is 110. Together it was 150. So now you have to increase it. Okay. So generally it's the first layer is costlier. So you don't increase the thickness of the first layer. So the second layer you can increase. So from 110, you can increase it to 130. You can increase it to 120 also. But maybe it will again fail. That's why I increased to 130 directly. So it's again optimization. Now if it is not failing at 120 and directly you have increased to 130, then you see 10 mm and 1 centimeter. 1 centimeter may look like this, but think about the entire road, say 100-kilometer road. 100 kilometer, 100 kilometer will be around 100 into 1000 meter, right? Multiplied by this 1 centimeter. 1 centimeter is 0.01, 1 by 100. So two zeros will get cancelled. So it is almost 100 meter square. Sorry, meter square of, and if you multiply the width of the road, so 3.7 meter, it will be around 7,000 meter cube for 100 kilometer. Just because you were too lazy to make it and check whether 120 was okay or not. So anyway, we will make it 130. Okay, we will make it 130. Now this layer has become 130. So can you please open again KENPAVE? KENPAVE. Now,
Yes, sir.
now you will tell me. Okay, you will tell me. So I will not tell you the trick now. I will start with new only. So you guide me. What shall I write in general? So this should be 1. Okay, and the coordinates 2. Then, or maybe I can show you. So in KENPAVE, the good thing is that the earlier data that you saved now, that you can reuse. So you can go to file, you can type old, so it will open this. So you can open whatever the folder. Okay, this one. So if you open this, all the values will be directly coming, but you need to confirm everything by clicking one by one. So general, then z coordinate, this layer, how much, what coordinates coming before. Okay. So what will be the z coordinates? You will tell me. What are the z coordinates this time?
Sir, 15.
15. Okay, and second one?
60.001.
Are you sure?
Earlier it was, sir, 15. Now it should be, sir, 17.
Yeah,
Because
we have increased the thickness, right? So from 110 we increase to how much? Increase to
130.
30. So 130 plus 40, it is 170 now, isn't it?
Yes, sir.
So it will be 17. Then what will be the remaining one? This one? It will be
62.001.
62.001. Okay, very good. Now layer. Why it's not coming? Okay, thickness, can you tell me?
Sir, 17.
17.35. Is it coming for you guys?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Maybe I need to free some space. That's why it's not coming. So what will be the layer of the second thickness of the second layer?
Sir, 45.
45, which is not changed. Okay.
Yes.
45 and 55. Then modulus same 6 zeros. So then কিমান আছিল 224 400, right?
Yes, sir.
71800.
8,000. Yes.
Okay. Okay. Then load here will it change? No, right? Will it change?
No, sir.
Nothing. Load will be 1. Contact address 10.66. Contact person 560. YW0. Sorry, 32. Right? XW0. 3. Zero, 10.66, 60. Everything done. Save as. There's the demo 2. Saved. Saved. Exit. Come there. It's run. Go and check. Okay. Now you can see 0, 17, 62. Okay. And all my other properties can be seen here. Okay. Or maybe I can print out. Okay. All right. Go back. Okay. There's the demo 2. Now we check. Now you tell me. You tell me now. Which one is maximum? Which one is? What is the value of epsilon v and what is the value of epsilon t? Directly you tell me in microscale. Are you able to open the file?
Sir, I'm browsing.
Anybody else? Will tell
Sir,
me.
which values, sir? It's
Epsilon
open
t, epsilon t and epsilon v. Finally, we need that one only, right? For that only, I explain everything, like which layer to see. Then we need to check which one is maximum. So now you directly tell me because you already know.
now. Sir,
layer to
epsilon b is, sir, 2.571.
No, microstep.
Okay, sir. Macros.
257.1.
257.1.
Okay. So it has again decreased, I think.
Yes, sir.
Anyway, the earlier was also okay, but since we have increased the bituminous layer thickness, so it will decrease.
Yes, sir.
It's okay. Whatever epsilon t,
So epsilon b. So 154.5.
154.5. What is the permissible value?
The permissible value was 155.47.
So is it okay?
Yes, sir.
It is okay, right? All right. So can you switch back to my second screen?
Yes, sir.
Okay. So 257.1 and 154.5 microscale. So in this case, again, this value should be different. So the highest is under these 2 points. So now both are okay. So hence the assumed materials and thicknesses for the pavement are okay. So what are the assumed materials and thicknesses? What are the materials for the surface course? What we assumed that my material was bituminous concrete with modified binder. So it can be PMB, it can be CRMB, it can be NRMB, but it has to be modified. So, and what is the thickness of that layer? 40. 40 is okay. Then for binder course, we assume dense bituminous macadam with Vg40 bitumen. We increased from 110 to 130 and 130 plus okay. So together it was 170, right? So 40 and 130. Base and subbase, we assume this is wet mix macadam, granular subbase is 250 mm and 200 mm. Together it was 45 centimeter, right? The subgrade is soil obsidian 9%, it is half phase, but we provide 500 mm. Okay. So understood?
Yes, sir.
The entire
Yes, sir.
story, have you understood?
Yes, sir.
Like how do you calculate permissible strain? For that, what do you require? PDF, how to calculate PDF, how to calculate this. So can we simply now go back and start from, simply recap everything so that you understand in a better way. Okay. Simply just 5 minutes, 5 or 10 minutes. So we are doing it for using IC37. Okay, so different thicknesses were there. So all the thicknesses, some given ranges are there, but we need to find out the actual thickness and what are the material types to be used based on the requirement for how many years, what is the traffic, growth rate, including everything, right? So we learned fatigue cracking, we learned rutting, what is rutting, why it happens. We learned the critical positions, right? So we learned about different catalogs, which catalog to use, then what are the critical points in different catalogs. Okay, so what is fatigue cracking, which point is critical in case of fatigue cracking and which point is critical in case of rutting. So we need to find out particle strain at the top of the subgrade and tensile strain at the bottom of the bituminous mixes, right? So we understood that the permissible strain should be greater than the generated strain. Alright, so in order to find out both, we have say for permissible strain, we need to first calculate the design traffic. So design traffic has many parameters like A, D, F, R. So we learned all the parameters one by one. What is A, how to calculate A. Okay, what is D, how to calculate D for different types of roads. What is F, how to calculate F if the Excel spectrum is given like this. We solve this numerical, and also we knew that we can assume this value of this PDF F if we know the traffic volume, right? So what is equivalent Excel load factor? So that also we assume why it is to the power 4, that we also discussed. We solve this numerical. What is design period for different category of roads? The design period is different, right? What is R? If nothing is given, what should be the value of R? That also we learned. Then we learned about these criteria. Okay, so for subgrade rating, how to calculate this permissible particle strain, and for fatigue cracking, how to calculate this tensile strain, right? So for that we need to assume the materials. So for different materials, different modulus of elasticity, Poisson's ratio, those values to be found out. So we started calculating everything from subgrade, right? So from subgrade, what is the elastic modulus of subgrade? How did you calculate? For that, we need to know the severe value of the soil. From the severe value, we can find out what is the elastic modulus or modulus of resilience of the third layer, the subgrade layer. So we calculate that. Then with the help of that, we find out the modulus of resilience or elastic modulus of the above layers. Okay, there can be different types: granular subbase, then cemented base, and in granular base, we need to check whether both the layers are granular. Then we can consider the same formula, but in this case, the thickness of the granular layer will be higher. But if it is CTSB, then again we need to change it. It's cemented base. Relief layer also we have learned. Then bituminous layers. For bituminous layers, what should be the modulus of resilience? And we know that this modulus of resilience depends on the bitumen type you are using. So which bitumen to be used, which bituminous mix to be used based on the traffic criteria, that also we learned. So for surface as well as binder, we learned for both based on the traffic. Okay, so after that we learned what should be the modulus of resilience of that. So IRC already recommends these values, so directly you can take this. If you don't want to test the materials in laboratory, directly you can take this as E value. Okay, and these are Poisson's ratio value. So this is 0.35, or subgrade it is 0.35, not 0.30. Now we know that in order to start anything, we need some initial trial thickness. So for initial trial thickness, we know the severe. Okay, we should know the severe, we should know the traffic. So in our case, the severe percentage was 9% and traffic was 84. So this plate 4 was not used. We used a different plate. I think plate 5 was something we used. So these plates are there in IRC code. I will share the codes with you tonight. Then this was our challenge to design a road from Mumbai, Chennai to Mumbai. So it is a 4-lane divided national highway, and what we did, we estimated the design traffic based on several assumptions. So what are the values we took, why we took, so everything we discussed in details, right? Then we calculated this design traffic and found it to be 84.9 MSA, right? Then we decide which catalog to use, since there is no scarcity of missile aggregates, so catalog A was used, and severe was supposed to give it as 9%. So using plate 5, we know that these are the initial thicknesses, okay, for different layers. So these two are combined together, so it is 150. This is 450. Okay, now also, as outlined in IRC, we know the based on the traffic, we can find out which type of materials to use, BC, DPM, 3G40, like that. Now after knowing this entire things, we start calculating this E value and mu value for all the layers. This MRS is basically elastic modulus. So for subgrade, since it is 9% severe, so we use this formula, we found out this. For base and subbase, we use this value, okay, here, and thickness of both two layers combined, 450, we put it here. So these are empirical formulas, so you have to also know which unit to use. You cannot write 45 centimeter here, you will not get the result, so you need to write in mm. So if you open the code or open this PPT, you will understand which unit to use. So this is the summary of trial 1. These are the values and these are the thicknesses. Okay, so now we need to find out this epsilon V and epsilon T, right? So first find out the permissible ones using this formula. The permissible epsilon V is this much, epsilon T was this much. Now next we need to check whether the permissible is greater than the generated one or not. So in order to know the generated one, we need to know the software KENPAVE. IIT PAVE is also there, because IIT PAVE I can share the software, but I face lots of difficulty, to install that software. Some Java applications needs to be installed, and exactly which one worked, I don't remember. So that's why I didn't want to give you. But same analysis software only, it will give you strain based on the load. Okay, strain at different locations. So we understood why, how this contact radius, what is tire pressure, what is contact pressure, same thing. Then what are the different parameters that are required in KENPAVE. So we also calculated the coordinates of different critical points. Okay, different critical points in our pavement. So these are the points, 6 points. So for that we have used KENPAVE. So these are the things. This, like that. So we calculated the generated strain at different points and found out which one is the maximum. So 174 is maximum of this, and this. Okay, in this plane. And in this plane, this vertical strain, this maximum is this one. So we finally consider these two values within this, but this one is coming lesser, greater than permissible one. So we need to alter something, either the material property or thickness. My question here is, if suppose this we have got okay, this is okay, and this is I have got 32 microstrain, then what would have been your strategy?
Sir, the thickness of the second layer should have been altered.
Yes, since this is okay, so we can increase the thickness of, so this is 15, this is 450, so we may take 550 centimeter. Okay. So anyway, you can check the new thickness and again calculate the strains, and for this strain it's coming okay. So hence the assumed materials and thicknesses are okay. So understood this entire concept? Any doubt?
Yes, sir, no doubt.
I want to hear this from all of you.
Yes, understood.
Understood?
Understood, sir.
Okay. Giri sir?
Yes, sir. Understood.
Understood. So this is the final design, and this is not an assignment because I don't give marks. I cannot give marks anymore. This is just a homework. If you want, you can do. If you don't want, you don't do. Just to, revise the things. Okay. So you can do separately. You can check your results with each other. Then I think you will understand how everything is done. You can attach the KENPAVE design, and if you feel that okay, sometimes happens, good students, whenever you do something, you want to confirm whether it is okay or not. If you want to confirm, first you confirm with your friends, then send me a WhatsApp message in this number again, with the KENPAVE printed diagram, and also any doubt if you have, or finally the thicknesses. What are thicknesses? What are the material properties? Okay.
Yes.
Thank you.
Thank you, sir.
Thank you, sir.
Next,
Thank you, sir.
next I want to know what you want to learn. Directly shall I move to concrete pavement, or see, this is where you used software KENPAVE to find out the strains at different points. But what if the softwares are not available? You have to do it manually. So manually also it can be done. Just finding out strain if you know the loads and the stresses. So do you want to learn that, how to do it manually? Because that is called analysis. This is design. Design is finding out the thicknesses, but that part is called analysis. Analysis, stress analysis, strain analysis, how to find out strain, how to find out.
Sir, are the procedures here same for rigid and flexible field beds?
No, completely different.
Sir, the analysis part.
Analysis part also completely different.
Sir, I think we should move on to rigid pavement, and then if we have the time, we can come back to the manual method.
Okay, if you don't have problem, then it's okay, because the modules I prepared, it was like analysis and design of flexible pavement. So it was flexible pavement together, and actually in rigid pavement, this analysis part is done using KENPAVE. Okay.
So there are no manual methods in rigid pavement.
Manual methods are there, but you know, what I can say, the formulas are very, very huge. I will teach you that also. Don't worry. You get this Westergaard equation, and sometimes not directly the equations, but some concepts are asked. I'll cover that portion as well. And for designing of concrete pavement without analyzing is also possible. So that thing is done in Excel. I will share the Excel file with you, but again only with the interested ones. Okay. So next, are you moving to rigid? Okay. Or let me see, whatever like seems better for you guys, that I will do anyway.
Okay, sir.
Okay. Okay. All right. Thank you. We will again meet in next Saturday, 6 o'clock.
Okay, sir.
All right.
Thank you, sir.
Thank you.